All right. Hello, everyone. My name is Sebastian Alvis. Thank you for coming to my demo here on deploying cloud infrastructure with Terraform on AWS. I am a data scientist at UW. I work on the Pangeo project, and a lot of the work I do is developing infrastructure for Pangeo. So I've done it a couple different ways, and this usage of Terraform, this tool, is probably my favorite way so far. Um, Terraform is an infrastructure as code tool, and that sort of has two big parts to it. One is the infrastructure, which is the things we're going to deploy on the cloud, and so that could be as simple as one machine. We can log into it and do some things, or it could be a whole cluster, hundreds of machines that you're scaling whenever you need more computing power for your very high-end computing tasks. Um, and the other part of that is code. Uh, and so I get to work on this just from my local laptop here, and the code, it looks just like configuration files. It's very JSON-like, um, and it's very simple. All right, so here is Terraform website. This is the logo. I'm going to be working with the Terraform deploy repo here in the Pangeo data organization. This example sits under the AWS examples folder and is called minimal deployment tutorial. Most of what I say will be in the README, so you can follow along there if you would like. And to start, I guess I'll just show you this little diagram I've put together to showcase one of the things you can do. This will be our second example. And so this is sort of a hello world style cluster that could host the Jupyter Hub. I've deployed this example before. We won't be deploying the Jupyter Hub itself today, but all the infrastructure underneath will be there. And so that'll mainly be the cluster and then a lot of networking pieces to help facilitate the internet traffic in and around the cluster. Now, I've mentioned that I've deployed infrastructure a few ways, but I prefer Terraform. And there's several choices you could make. You've got your cloud provider that you need to pick first. We've generally used AWS, and each cloud provider has their own um, console, like a website you can go to and click things to set them up, and their own command line tool. Now, if I was just going to deploy a single machine on the AWS console, which is here, it wouldn't take too much effort. I can click this little launch instance button. It's asking me what kind of machine image I want. So I'll pick this one. And it's saying how big do you want the machine to be, and this is free tier eligible, so I'll go ahead and pick that. And I've got this review and launch page, and when I click launch, it'll just take a few minutes to spin up, but it's ready. And you might think, well, that's pretty easy. Why can't you do that in general? And I think the main issue is that for anything more complicated than a single machine, it's just too difficult. It becomes a lot easier to use any command line tool than the console in general. But Terraform in particular has the advantage that since it is not tied to a specific cloud, you can deploy things onto any of the clouds. So once you have gotten some good practice deploying on AWS with Terraform, then you can kind of take that knowledge and translate it to Google Cloud or Azure and deploy things with only a few changes. And the other really big thing that we like about Terraform over the cloud-specific command line tools is that Terraform tracks what it has created. So if you're running the same command multiple times to say, hey, build the infrastructure, it won't give you any errors. It will mostly just stop and say, hey, everything's built, you're done. And if you want to make little incremental changes, what Terraform will check is, okay, what have you deployed and what do you want to deploy? And what's the minimal difference between them? What is the least amount of work Terraform can do to deploy that change you've set up? And it will just deploy that. Um, this also means that it's very, very good at removing everything that you've deployed. So one of the problems we have in the console is that you will deploy some complicated infrastructure and then you won't quite remember all the pieces when you're tearing it down, and then something will linger on your account and then cost you charges over a bit of time. And that won't really happen with Terraform, because when you run the command to tear down your infrastructure with Terraform, it sees everything you've built and can take it all down. It makes it very easy. Um, so there's a couple things I'll have listed in the README here that you want to make sure you have installed if you want to run these examples. And as part of the AWS command line interface, you will need to have an AWS account and configure it. And they've got instructions here if you want to do that on your own time. But then you can just clone this repo and navigate to the folder. We'll go from there. And so what I have here is just my terminal. I'm on Linux, and my text editor of choice, which is Sublime Text 3. And that's all I really need to work with Terraform. It's very simple. And so to start, we're going to go into this subfolder, which is EC2 tutorial intro, to have a simple example that we can use to look at a lot of Terraform code. And so all this example is going to deploy is a single instance in the AWS cloud, like one machine, and pretty straightforward. So on the right here, I've got my main Terraform file, ec2 main.tf, and there's a couple things we can see in this file, and we'll go over them. So the first is we've got this Terraform block. It tells Terraform what version of itself to run. Then we've got the provider block, and this is really important. Terraform doesn't inherently know how to talk to the AWS API, but this provider block does. It helps translate Terraform configuration into AWS API calls. There's lots of providers to configure to different clouds. You can configure providers for Helm. You can configure providers for Kubernetes. It's pretty good. Now in here, we've got two things. It's var.region and var.profile. These are input variables. I have actually defined them in this EC2 variables Terraform file. You see there are 3 there. We're only using 2 for that provider. And they've got some default values, but they can be overwritten. And we'll get to that later. But for now, we just know that the value of these 2 variables are going to be provided to the provider block so that it knows where to deploy and what credentials to use on my local computer. The other way we can sort of take in data for our Terraform deployments is with data blocks. So this block is an AWS Amazon machine image. So it's a specific image that we deploy our instance with. And I've named it Amazon Linux, which is just what Terraform knows it to be named as. It's got some filters. It'll do a search on AWS's site, and then it will return only the most recent one. And the last block we have in here is a resource block. And this is the main meat and potatoes of Terraform. The resource blocks are actual infrastructure. And so this one is an AWS instance, which is our single machine. We've named it test EC2 for Terraform. And it has a couple settings set here. We can see that the name we're using is from the deployment name variable. And we see that the AMI is set to what looks like a parameter of this data block, and that is what it's doing. So all of the blocks have outputs, and you can reference outputs in other variables. And so here we say, I don't want to have to run the data block and then manually write down the result and put it in here to tell it what AMI to use. And so we don't have to. We can programmatically reference it, and that makes it really nice to not have to hard code a lot of your settings. And then in the same way that each of these blocks has outputs, we can have outputs for an entire folder. And so in this EC2 outputs file, I've got a couple things defined. I just want it to tell me what is the ID of the Amazon machine image that we're using, and then what is the Amazon resource name of our little EC2 instance. And so once the Terraform command's complete, it'll show me both of those things, which is also helpful to know that the command is done. So with that under our belt, we can look to deploy this. Now, I have told it to use my default profile, and I know that will work for me because my profile has admin privileges. I'm not really going to go over what are the privileges you need to deploy this example. It'll be easiest if you have admin. Um, but you will need the right privileges to run things, or Terraform will be able to do it. Um, so to start for deploying this example, I talked about overwriting these, and so we'll just do that here. So I've set up this your EC2 values file. I've put in some defaults that I want to use. So I'm still going to deploy to USWS2 and use my default profile, but I'll go ahead and name the deployment adds a demo deployment. And so I'll just need to tell Terraform to use this file when I run commands so that it knows to overwrite those variable inputs. So back over to the terminal, I am in the EC2 tutorial intro folder, so I'm ready to go. Before I start, I need to initialize Terraform. So I'll do that with the Terraform init command. And so what that'll do is it'll download any provider blocks so that it actually has the code to run those things. And then it'll tell me it's been successfully initialized. So that's good. Now, before we go and deploy things, we want to make sure we know what we're deploying. So we can use this Terraform plan command to check that. We can supply the variable file, your EC2 values.tfvars to it, and so it'll know what to name our EC2 instance, and run that. And so the first thing it'll want to make sure it knows what the data is going to be, so it will find that data block, and then it'll show me the plan. And so right now, the only thing it needs to build, one to add, is this EC2 instance. And it has a lot of information that it knows the EC2 instance should have. Most of it doesn't know what it will be right now. But we like to use the plan command because it helps us make sure we're deploying exactly what we need to. But if you don't want to run the plan command, that is fine. You will see the plan for Terraform every time you run a creation or deletion command. So now we can use a very similar command. Instead of Terraform plan, it'll be Terraform apply. And the apply command will ask Terraform to set up our infrastructure to be whatever we have in these files. And so if that's only slightly different than what we've deployed, it'll try to change things as little as possible to get to our desired end state. For now, we don't have anything deployed, so it's just deploying that EC2 instance. And then the same way we did in the plan command, we want to supply that variable file with the var file flag. And so when we run that, it'll first go grab the value of that data block and then show us the plan again. And so we can see, yes, this is just the EC2 instance. Everything looks good. And then it'll ask if we need to approve our plan. So I'll say yes. And it'll take 20 or 30 seconds to make this EC2 instance. And then Terraform will let me know it's done. A common thing you'll do with the EC2 instance is that you'll want to log into it, use a little SSH command. You'll need a key pair for that, and there's some links in this README for how you could do that, but I'm not going to go over that here. But it looks like we got this completed. We can see the two outputs that we defined here. So we've got this AMI ID. We could look that up on Amazon if we wanted to see some specifics about it. And the Amazon resource number, which is only going to be, that one's only going to be specific to me. You'll probably have something that looks different, but it looks like it's good. And so you could play around with this a bit. It should be free tier eligible, but when you want to tear it down, all you have to do is run Terraform destroy, pass the variable file again, and then Terraform will actually give you another plan. But this time it says, oh, I've got one to destroy. It's got a bunch of the red hyphens instead of the green plus signs. And so I do want it to be destroyed, and so I'll hit yes. And this will still take 20 or 30 seconds to tear it down again, but then it'll be done. I don't have to worry about something lingering on my account. Did I forget to shut it down? And it's pretty slick. And while that's tearing down, I can change up my windows a little. But that is the EC2 example. So once this is destroyed, we're going to move on to our simple cluster deployment. And hack away at that. So we'll back up a folder, back in the minimal deployment tutorial folder. And so as a reminder, this cluster is going to look like this. It'll have some networking pieces, the Kubernetes cluster, and a couple sets of nodes in it, or machines. Now, to start, we are going to use one more block that Terraform has, and this is called a module. And so modules are essentially collections of resources that you can tie together, and they're useful for us because I only have to define, this 15 lines of code to set up all the networking for my Kubernetes cluster. And there are a lot of resources in there that I don't really have to know very well in order to deploy it with Terraform. It makes my life a lot easier without having to sacrifice security or feature sets for it. And so we've got a module for the networking, the virtual private cloud, and we have a module for the Elastic Kubernetes Service, or EKS cluster on Amazon. And so we learned a couple of the features that Terraform has in the other example, and they're a little bit extended for modules. So they both of these modules, since they're AWS specific, require the AWS provider, but we were all going to use that. The EKS module also requires a few other providers, so we've shown those here. It just needs a couple other things to download so it can work. Now, both the modules have outputs. We can't see them. They're defined online, where the code is. But we do see that we can use outputs from that VPC module to feed into the EKS module. And so this is handy, one, right? So we don't have to hard code or anything. Anyone can deploy this and it should work fine. But two, this tells Terraform that there's a resource dependency. It says, hey, you can't create the EKS module until you have this VPC ID variable. And so what Terraform will do when it's creating things is make sure it creates the VPC resources first, and then when those are done, it can create the EKS cluster. And I think the last thing I can say on these modules that's really cool is that they were both developed by the open source community with Terraform and AWS. So that's really cool. So we've got the EKS module, we've got these two worker groups, the core and the user, and we've got some data blocks, some provider blocks, and I think we are good to go. So as we did before, we can run Terraform init to set up this folder, since Terraform doesn't check anything but the current working directory. And so Terraform downloads the providers and both the modules so that it has all the code ready for deployment. And again, for deploying, you will need to have the right permissions. There's significantly more permissions you'd need for this, but again, it'll be easiest if you just have admin permissions for your AWS account. And so now we'll want to set up our input variables again. So we've got another file here. The variables file looks very similar to the last one. And we've got your cluster.tfvars. And so I will go ahead and have a couple variables set. I'm deploying in US West 2 again. I like my default profile, and I'll have this. I'm going to leave an underscore after this deployment name, but that's because I know there will be a little text after that for each of the names for the modules. And so I can again run the Terraform plan command. And there will be quite a few resources. I believe it's 49 that the plan will say are ready to set up. And that's, there's a lot of networking to do, and you don't have to scroll through all of these before you deploy it, but at some point it'll be good to know all the bits that you're deploying in the cloud. So for now, we'll say, okay, there are 49, that looks good. I can run the Terraform apply command. And I'll make sure to pass the TFR's file. And what I'll say for this deployment is that one, it can take 15 or 20 minutes to create, so I'm not going to show you my screen that whole time. And two, it costs maybe $5 a day if the cluster's not doing anything. So if you leave it up, just sort of keep that in mind. But it's not too expensive to leave up if you're testing things. And so I'm going to approve this plan, and you'll see it's creating a lot of different things at once, it looks like. And so Terraform, I think by default, will create up to 10 things at once if there are no resource dependencies. And then it'll have to slow down if there is a specific thing that is in the way. So as we can see here, the EKS cluster is one of the resources it needs to wait on for a while until it can create the rest of it. And so this particular resource can take 15 minutes by itself sometimes. But I'm not going to wait for that to happen. I actually have a terminal saved with the output. So let me make this a little bigger. So this is the output that I get when I finished creating it. It's got some cluster endpoint. You got a lot of the information that you'd need to properly configure to the cluster. I've listed some steps in the README on how you could connect to this cluster, and then you can use some Kubernetes and Helm commands to inspect it or deploy software onto it. And so that'll be the end of the demo. I think we've hopefully you've learned something about Terraform and you find it useful. We've done a little example deployment of an EC2 instance, single machine, and then also a primitive cluster that you could host the Jupyter Hub on. Feel free to keep this running and let me know if you have problems in the Q&A. And if there's spare time afterwards, maybe we can look at deploying some software onto the cluster. But yeah, thank you all for coming, and let's get to the Q&A section.